lesson 7.3 on simplifying algebraic expressions. We had a lesson early on in the year on chapter 2, lesson 4 on simplifying numerical expressions. You could look back on that page to do a little bit of review. You'll basically see these rules that when you have order of operations, you do parentheses first and other grouping symbols, powers or exponents, then multiplication, division, left to right. It could be division, multiplication, whichever comes first. And then you'll be down to addition and subtraction, and you work left to right. If you have a subtraction before an addition, as you go left to right, you do the subtraction first. Just a little more details about other grouping symbols. You might have an absolute value symbol that puts something like 10 minus 6 together, plus 3. And you would work in these brackets first. Or you might have, maybe it's a square root symbol, 10 minus 6, plus 3. And you do things under the radical, or the square root symbol, before you do add 3. Or you could have a division bar and have something like 6 plus 2 over 2 to the second power. And you do everything above the bar and then everything below the bar. So this effect would be the same as 6 plus 2 grouped with parentheses divided by 2 to the second power. So this is a grouping symbol. The division bar groups things together. So let's look at some examples. It's with algebraic expressions, so you're going to see variables. You might see some numbers mixed in with them. But this is going to incorporate the distributive property, which we had in 7.2, as well as other concepts we've learned. We'll do inside the parentheses first. It's not a bad idea to change this to add the opposite, to keep change, which results in negative 4x multiplied by 1/5 minus x over 5. And we can put a 1 under this to make it a little more obvious what we do. So now we have 1/5 the fraction times negative 4x over 1, numerator, denominator, multiply the two numerators, and we get 1 times negative 4x is negative 4 over x, 5 times 1 is 5, and this is a kind of a contrived problem, because we have the same denominator, so we can add these. And we also have the same like terms in the numerators, so we can combine these two things. We can do something with the negative 4x and the x. But let's make this add the opposite first. And this would be, how many x's here? There's no coefficient there. Doesn't help us out, but we know that's a 1. So we have negative 4x plus negative 1x. Negative 4 plus negative 1 is negative 5, and we keep the same label. We don't change the denominators when we add. And think about what you can do with this. We can divide 5 into 5 and 5 into negative 5. 5 into 5 gives us 1. 5 goes into negative 5, negative 1 times. And we can simplify this. We can just think this is a little tricky one. And this would be, I'm not sure we count this as an incorrect answer, but it's just not quite done yet. This is the same as the opposite of x, because we can take that as, we can always take the 1 out of the denominator, and then we don't need the coefficient 1, just put the opposite of symbol there. So that's the first of, I think, 3 examples I want to show you. I think this is problem number 5 on page 160. 3x plus 8x plus 8y plus 2x to the second power. So we're looking for, it's all addition except for the powers. We can go ahead and take care of that first, because that's what our rule says. So we would say it's still 3x plus 8x plus 8y, and 2x times 2x would be 4, is a plus. 2 times 2 is 4. X times x is x to the second power. So now we have 4 addends, and we're just looking for anything that's terms that are like each other, which would mean same variable to the same power. And there are only 2 terms that are like each other. So there's only really one thing we can do, and that's to combine the 3x and the 8x to give us 11x plus 8y plus 4x to the second. There's one other thing that we should do to follow the protocol, and that is to put things that have the highest power first, which would be this, 4x to the second, and then we go alphabetical order, and x comes before y, so it would be plus 11x plus 8y. Same thing as this, really no difference in value, it's just following sort of the way you do things with algebra. And then the final example I picked out is the most difficult problem, I thought, on page 160, which is number 8. So it incorporates a lot of kind of tricky things. It's the opposite of r times 2r minus s plus r to the second, that whole quantity, minus r to the third power. Okay, the first thing that we do work in parentheses, but there are no terms that are like each other, so you really can't simplify this at all, other than it would be a good idea to make this add the opposite. Then we have the opposite of r times 2r. Now you can, I think I would allow you to just do this and write down the product. I think for the sake of clarity, I'm going to write it out in a longer manner so you can kind of follow a little bit better. So it would be the opposite of r times 2r, and this is the part where I'm writing it out, plus the opposite of r times the opposite of s, plus the opposite of r times r to the second power, minus r to the third. Now I might want to make that plus the opposite of r to the third, but let's kind of see how this works out here. So this would be, we can make this put a 1 here if it makes it plainer to you. Negative 1 times positive 2 is negative 2. R times r is r to the second. Plus negative 1, I can put a 1 here too. Negative 1 times negative 1 is a positive 1. And r times s is rs. And then negative 1, I can put a positive 1 to think of it. This is going to be the opposite of... I know I made a mistake here somewhere. But I'm not sure where it's at. Oh, I'm finished up here. It's the opposite of r to the third minus r to the third. I know that's not right. But I don't see anywhere I made a mistake. So I'm just going to work through this and see where we come out. Because I know what the answer is, and somewhere we should have a positive here somewhere. Unless I just copied the problem incorrectly. But anyway, what this it looks like it's going to be is make this plus, negative. So we end up with, there would be 2 of these. So we can't combine anything here except for these 2 terms, and it'd be a negative 1 plus a negative 1, which would be negative 2r to the third. Then this would be minus 2r to the second plus rs. Which I know according to the answer key it should just be this. So I'm wondering if I copied something incorrectly. Let me check on the book here. If I didn't copy it incorrectly, I'm just going to leave it up there because I think that's what the answer would be. So I swear, I don't see it. Oh, yep, I do see what it is. I'm just going to go ahead and correct this. This is the right answer to what I copied down. But what I missed was, in the book, the problem is minus the opposite of r squared, which would make this plus right here. This would be plus. This would be plus positive r to the third power. And so what would happen here is you would have add negative 1r to the third and then add positive 1r to the third, which makes a 0 pair. So that would just be a 0. That would disappear. And according to the way the problem is presented in your book, which I miscopied, but this is what the answer would be. So there we got 2 for the price of 1.